Hello all, this is my second day of this video tutorial series, and today I am very quickly going to explain the current electricity. As I had already told you yesterday, electricity exists in two forms. One in the form of static charges, that is charges at rest, and another one is moving charges that are moving. Now moving charges constitute electric current. Now, to understand how electric current flows, how do charges give rise to electric current, we have to understand the basic structure of a metal or a conductor. Now, I'm going to show you a figure which I think will be able to explain this very more clearly. If you can see on the computer, this is a photo of a metal which has electrons denoted by these blue dots, and these are atoms denoted by the red dots, red circles basically. So this is the structure of any conductor. A conductor has atoms and free electrons. Now these free electrons are in random motion. See, they are moving randomly. This is going here, this is going downwards, this is again going downwards, this is going left, these are going in any direction. So if the electric current is flowing, if the charges are flowing randomly, there won't be any electric current flowing in the conductor. But if you look at this photo, see, the charges in this photo, the charges are aligned. The charges are aligned. Now, why are the charges aligned? Why are they moving in the same direction? Whereas in the photo that I had shown before this pic, the electrons were moving in random direction, but in this pic, the charges are moving in a particular direction. This is because of application of a potential difference. Now, let me reiterate, let me recapitulate it very quickly. First of all, what is electric current? Electric current is nothing but it is the charges flowing through a cross section area. See the circle that is denoted by the dots, it is known as a cross section. So electric current is nothing but it is the number of charges flowing through a cross sectional area in a unit time. So electric current is nothing but, see, I hope you are able to see this thing. Electric current is nothing but charge flowing per unit time. Now see, charge is flowing over here also and over here also. So what is the difference? Here in this picture, the charges are flowing in random direction. Because of random direction, we won't be able to get any measurable electric current. We won't be able to get any useful electric current. But if we apply a potential difference across the ends of this conductor, we get the charges aligned. See, these charges are aligned. And because of this alignment, we get some useful electric current. Now, the thing that you might have been able to understand from this topic is, first thing, what is electric current? Let me recapitulate it very quickly. Electric current is nothing but it is charge flowing through a cross-sectional area per unit time. So, an electric current is denoted by capital I. It is denoted by capital I, and its unit is ampere. AMPERE. So, electric current is nothing but charge flowing through a cross-sectional area in per unit time. So, I is equal to Q by T. Now, what is the condition for flow of electric current? The condition for flow of electric current is some potential difference must be applied across the ends of the conductor. You must have used, you are using mobile, you are using all kinds of gaskets. So does mobile work without a battery? what does a battery do? Battery, it is a source of potential difference. So when you buy a dry cell from market, it's written 1.5 volt. So what is that 1.5 volt? 1.5 volt is nothing but it is the potential difference. And if there is some potential difference, because of that potential difference, all the electrons are aligned and flow in a particular direction. And when the electrons or charges, they flow in a particular direction, they constitute some kind of electric current. Now the next important thing that we have to know over here is, like yesterday we read about potential difference and how to measure potential difference. Potential difference is measured through an instrument known as voltmeter. Likewise, electric current is measured by an instrument which is known as ammeter. I can show you ammeter on my computer screen. See, this is an ammeter. Can you see that? Okay. So this ammeter is used to measure electric current. And you know what? This ammeter must have a very small resistance, very low resistance. When we read about resistance, I will be explaining why do ammeters need to have low resistance. Okay. So, how should we get continuous flow of electric current? We can get a continuous flow of electric current by applying some potential difference across the ends of the conductor. If there is no potential difference across the ends of the conductor, there cannot be any measurable electric current, as I have already explained with the help of two figures. Because electric current will only be measurable when the charges are aligned in a particular direction, and that alignment can only be created, that alignment can only be achieved with the help of a potential difference. Now, what is the direction of electric current? As you know, in an atom there are neutrons, protons and electrons. Of course, neutrons and protons are bound inside the nucleus and hence they cannot flow. They are not supposed to take part in most of the chemical reactions, or most of the chemical reactions that I know about. And it is the electron which takes part in any chemical reaction, or they get out of the this atom and they are known as free electrons. So basically, electric current is because of flow of electrons. Now see, the electrons have a negative charge. You already know about it. Since electrons have a negative charge, so I have explained it in my earlier video that unlike charges attract each other. So when we apply a potential difference, when we apply any battery, so electrons will flow towards the positive terminal of the battery. Because electrons are negatively charged, they will flow towards the positive end of the battery. This direction, this negative to positive direction of the charge is known as real current direction. This is known as real current direction. This is a very important thing. Electric current is constituted by electrons, and electrons will flow from negative end to positive end. And this negative end to positive end flow is known as real current direction. But we don't consider this to be the direction while studying physics. In physics, we consider positive terminal at a higher potential and negative terminal at a lower potential, and therefore conventional current direction is from positive terminal to negative terminal. Real current direction is from negative to positive, because electrons are flowing from negative terminal to positive terminal. But since positive terminal is conventionally, as a matter of convention, positive terminals are supposed to be at higher potential and negative terminals are supposed to have a lower potential. That is why we consider that the current flows from positive end to negative end. I guess this is all for this topic, and you can always let me know on my number if you have any problem. See you tomorrow.